All right, we are back again on chapter 5. We're in structural steel framing. You're going to think some of this is a repeat, and it is. I mean, you got structural steel framing. We had structural steel in floors. Um, I mean, an argument could be made that the book could be resplit up into just structural steel, floors and columns, and that kind of thing. But anyway, it's the way Ching did it, and that's fine. I don't care. And we'll just adapt, overcome, and persevere. Hoorah! All right, conventional steel frame structures are constructed of hot rolled beams. We've said this before. Structural steel is hot rolled. It's not cold formed. We'll get to cold form in a minute. Open web joists, metal decking, etc., etc. We've gone over all of that. Um, Now, this stuff is done, fabricated in a fabrication shop. It's trucked out. They got number tags on these that tie to an erection drawing set, and then they're pulled off the truck in order and assembled on site. Um, you don't want to be doing structural steel fabrication on site. You never get the thing built. All right, and it would be super expensive. A steel fabricator has the equipment to punch the holes. They're CNC controlled, computer numeric controlled, and a whole series of stuff from the design plans to the structural drawings to the shop drawings and then to the fabrication drawings. And then this stuff gets shipped out to the job site. Uh, Now, steel framing is most efficient when columns are laid out to support a regular grid. We've talked about this before. Um, a regular grid. And you start getting oblong, weird grid shapes and stuff, and um, it's just going to add cost to your building and runs into some problems. It could run into some potential problems. Column spacing equals beams or girder spacings. Well, of course it does. Um, the further out these columns go, the deeper the beams have to be. Um, Both the girders and the transitional beams. Orient the webs of columns, he says, parallel to the short axis of the structure of the frame. And then he says orient the flanges on perimeter columns to the outside to facilitate attachment of curtain walls. Well, these things only got two flanges. So what are you going to do over here? Well, the fabrication drawing, you have to in detail a curtain wall hanger off of the web of the beam for your curtain wall going in this direction. Um, Now, there are companies that specify, I mean, that they specialize in curtain walls. So you might subcontract with them to be a design consultant and do your detailing for your curtain wall. All this has to be done up front because all this adds to the weight of the building. And the structural engineer has to be aware of this. Um, so, resistance to lateral forces. We talked about this before. Making a rigid structure. Well, they're welded joints. Is it rigid? Are we going to cross brace it? If you cross brace it, it's can't really put a window in there now, can you? How are you going to skin this? Where are your shear walls going to be? Um, the structural engineer has to go through and do a moment distribution. When a wind or earthquake's pushing on this building and wants to make it fall down, where are all these moments going to go through these columns and how they're transmitted all the way down to the foundation? That's the structural engineer's job. The big thing you got to worry about is if I want to expose this steel because I want it to look pretty, like in the Centre de Pompidou in Paris, France, how are we going to fireproof this? Because fire code says you need to fireproof your building, and that's a good thing because steel will lose its temper after a certain temperature. Some say 800 degrees it begins. Some say 1,000. Some say 1,200. Um, if you go back and look at the videos of 9/11, those planes crashed into the upper section of both World Trade Centers. They disintegrated in there and started a huge fuel fire, that jet engine fuel. It heated that structural steel up so hot above it and below it into the heat affected zone that the steel just couldn't take anymore, and those bundled tubes let go, and the building collapsed all the way down through the center line. That's a good example of how heat will affect the strength of structural steel. Now, this is a curtain wall. We haven't talked about curtain walls yet. You got to skin. You got to put some kind of skin on it to keep the wind and the temperature and the rain and stuff off of it. So most of these buildings have some kind of curtain wall. Some of the curtains have windows in them. Some of them don't. How do you frame that curtain wall? How does it tie into the diaphragm floors? How does it tie into the structural steel? That's what all this is about here. And there are three basic relationships that may be established between a structural steel frame and the curtain wall, or cladding it supports, okay? Three basic. 1, 2, and 3. So you got column in front, column within the wall plane, and column behind the wall plane, okay? Here's a column in front, all right? All right, column behind. This would be a column behind the wall plane. We have an offset, and you got clips that hold this, okay? You got it in front, within, and then behind. But they all have to be fireproofed. Some of the fireproofing can be sprayed on. Sometimes they box these columns in multiple layers of sheetrock to get you your 1, 2, or 3 hour of fire rating. Wall units incapable of spanning between columns are from floor to floor, require secondary framing or mullions and shelf angles. So sometimes you have to have mullions or secondary framing to hold your curtain wall. That all has to be architecturally designed. Again, you get with your curtain wall people. The curtain wall framing or panels, the supporting structure frame may respond differently to variations in temperature. And that's a very true statement. If this is a lot of glass, it's going to have a different thermal expansion rate than the concrete and the steel will. That has to be taken into account. Sometimes you got to float that curtain wall, let it move on the outside of the skin. That skin's going to move back and forth. The wall may be subject to both wind pressure and suction, and we've talked about that before, about how wind goes. On one side it's pressure, on the other side it's negative pressure. On one side it's positive pressure, on the other side it's negative pressure. You may have to have spandrel units. Jack bracing is like a knee brace. They all go by different names by different people who make this stuff. If diagonals are used to brace a structural frame, they will affect the design of the wall units. I mean, I don't know, you might want to show your diagonal bracing, your X bracing, if this was glass, but you might not. This might be a solid wall panel. And then on the next bay that didn't have X bracing, you could put glass in there. This is not easy. This is not an easy profession. Construction's not easy. Structural engineering's not easy. Architectural design's not easy. It's fun, it's challenging, and it's rewarding. But it takes creativity. In Chapter 7, they talk more about curtain walls. This is just a sprinkling. You could specialize in curtain wall systems, just like you could in structural steel or concrete or masonry. For glazed curtain walls, you can see 831. All right, that's where the individual panels are glazed or they're inset in a steel frame. All right. All right. Most shapes, we've talked about these before. We had, I think, a larger collection of structural steel shapes in the floor section. Anyway, it's a W shape. It's round pipe, rectangular, square tubing, welded plates for girders. We talked about girders in the Hardy Toll Road. Welded plates are box girders. And I've never seen a cruciform or four angles welded together like that. I have never, ever in my life seen anybody use something like that. Now, I have used this quite a bit, where we would use a structural steel hot rolled member inside a large round formed concrete column, and you'd have your normal concrete reinforcing steel to support the concrete, and this would be one big super duper super strong concrete column. It's a composite column because we're using structural steel and regular concrete reinforcing, so they call that a composite column. Compound columns are structural steel columns encased in concrete, at least 2.5 inches thick. Why they make the distinction between compound and composites, they're the same. It's all the same. Sometimes you'll take a round pipe, if it's big enough steel pipe, and you'll put reinforced concrete in here. So you're doing a composite column backwards. The allowable load on a steel column depends on its cross-sectional area, its slenderness, its ratio. That means its length to its radius of gyration, where L is the unsupported length of the column in inches, and R is the least radius of gyration for the cross-section of the column. And we talked about this before. Got this long spindly column, but if I come in here and I rigidly attach something in the middle of that column, then this column's not going to be this long. This column's going to think it's this long. And it's going to have another column that thinks it's that long and not the full length. Now that's a layman's Reader's Digest version of KL over R. K is a stiffness, length, and then radius of gyration. So if you can bring a floor in to a long spindly column and attach it, then that column is no longer this length. Goodness, need another mouse. No longer that length. This column is now that length and that length. This length and that length. We just split it in half and stiffened that column up, and that column will hold more weight. All right. I welded up some big plate girders. I don't remember if I told y'all that in a previous video or not, for the Hardy Toll Road, going over the railroad yard on the Hardy Toll Road. Those beams are bent up, and they look like some crazy person did them. The reason we did them like that is because the railroad would not give us clearance to sink a column. So I had to go way outside the specs, the normal specs, and design a big welded box girder. Those things had real super thick flanges. They're 8 feet deep. Anyway, I think I've already stated on that. Estimating guidelines for steel columns. Oh my God, this is going to get you in trouble. These are rules of thumb you will get with your structural engineer. You will consult with your structural engineer for final design. You will consult with the structural engineer, somebody that actually knows what they're doing, and they need to be a PE, professional engineer, registered in the state you're doing your business in. You're going to want company in court if this thing falls down and goes boom. All right. But this gives you some rules of thumb for your general layout. 4x4 steel tube column may support up to 750 square feet. This is okay, but again, it depends on your floor load. It depends on everything, okay? But a 6x6 steel tube column May, and I love this, see, may support. Doesn't say it will, it says it may. It may. It may. Okay? This says may. Okay? This says may support. This says may support. This says may support. This says may support. So there's no guarantee. It says it may support. Okay? All right. Column spacing equals your beam span. Well, you think? Okay. Yeah, if these column spacings get further out, your beam span is going to get longer. So your beam's going to have to be deeper. Increased sizes or weights are required for columns supporting heavy loads. Well, no kidding. The heavier the load, the stronger the column has to be. All right. And then you got to worry about your lateral stability. And we've talked about all of that. We just did that up here in this KL over R thing. Again, what are you going to do as the architectural designer? You're going to consult with your structural engineer. You can use this to start with on your butter paper in your dreamscape, but don't be surprised if your mileage varies. Remember the term may as opposed to shall. All right, steel columns. All right, this is important. You will take a steel detailing class. Double wood beam or a steel connector welded to a column. You're going to have a steel connector welded to a pipe or a column, and then you can slide your beam over your wood beam, and then there'll be holes prefabricated in here by your fabricator, and for your wood joist. Steel beam connections, AISC, we talked about those before. This is considered a pin connection. It will not transmit moment. It will resist lateral movement this way, and it will resist shear movement, downward loading that way. Okay? All right. Go back to chapter 4 for steel beam and column connections. I already talked about that. Column splices. Okay, now why would we even talk about column splice? Because the higher up the building goes, the less weight the upper columns take, right? So, are you going to take a huge, big beam on the bottom and run it all the way to the top? Well, maybe if it's a mid-rise building, it'd be more economical to just use the same size column all the way up. That means your building's stiffer. But if it's a high-rise building, you're going to step these columns because the upper floors are shorter. I mean, they're not carrying the same load that the heavy columns down lower are, right? So you'd have to splice them. So this is a way to splice them. Okay. When a change in the nominal size of a column occurs, a thick butt plate welded to both column sections is used to transfer the load. All right. So you have this butt plate. Okay. Welded to this heavy honking column. Then you set the lighter column on top of it, an alignment clip, and then this alignment clip is welded. That bolting is to align this, and so you can shim it and plumb it. And then you'll take your welder, structural welder, and you'll weld all the way around this thing, all the way around the side. I'm surprised they didn't weld that. Maybe they don't need to. And then before you keep going up, these welds are going to be inspected. They'll be either radiographed or they'll be dye penetration tested for stuff that's not even a part of this course. I won't even go there. Well, porosity, penetration, that sort of thing. All right. All right. Another way to splice columns is with bolted plates. Now, one of y'all might be thinking, well, wait a minute. If I'm going to use this to hang a wall on, and this is a smaller column, and this is a fatter column, a bigger column, then my wall's going to have jumps in it? No. Your wall's going to come up, your skin's going to come up the same facial plane. You'll just have to have offsets in how you're hanging your curtain wall. This is all the detailing stuff that you got to worry about. Again, remember the devil is in the details. Now with these connector plates, or a backer plate, okay, um, this extends out beyond the face of the column. So you've got to be careful of what that's going to affect your finishing. Where is this going to be oriented? How am I going to hide this? How's it going to affect my curtain wall or something else? All right, here's another one, a plate to keep columns aligned until welds are formed. This is called a welded butt plate, butt connection, okay? All right, welded butt connection. You just take this column, butt it up against this one, and then you do a weld, okay? Most likely, this joint here, you have a flat, and then the column coming in from the top, it's going to have a groove, ground in it, cut in at the fabricator, and then this whole area is going to be welded. That will be welded. That'll be a groove weld. And then your designation will be your rod, like an E6011, E7018. It'll be part of your welding deal. If you want it welded all the way around, you put that symbol on there. All right. As the load on a column diminishes, different flange thicknesses may be used. Well, we already talked about that. This is an alignment plate. Here's your bolts. So this is an erection plate. This comes from the fabricator, already welded on this deal. You line this up, you plumb it, you shim it, and once you get a go on it being aligned, then you can come in here and weld this. All right, it depends on how heavy that steel is. You may have to preheat it, or you may have to anneal it. You may have to put heaters on it, wrap it, and heat treat that weld after it's welded up, depending on how much weld you had to do. Pressure vessels out in large refineries have to do that. Put a tent around that big pressure vessel, and you wrap that weld joint all the way around that pressure vessel with heaters, induction heaters, to heat that metal up, to anneal it, and let it come back down to atmospheric pressure. So it's all a part of the welding specification that you have to do. Column bases. This is a welded column base to a base plate. Again, non-shrink grout. Stiffeners may be required when a column bears on a thin base plate, or when a column needs to transmit moment to the ground. Okay, when you want this to be a rigid connection. All right. Base plates for large columns are set on leveling nuts before grouting. You see this a lot with those huge highway signs, highway lights. You got leveling nuts underneath here, and sometimes they grout them. The highway department sometimes doesn't always grout those, but they'll have leveling nuts all the way around the column. And then you want a dry pack non-shrink grout in here. A seismic foundation connection. This is a typical seismic foundation. It stiffens that up, and again, remember the seismic stuff we talked about? It allows that frequency, because this is going to do something like that, the snake dance, remember? And it stiffens that column up. Now we're light gauge steel studs. This is no different than the light gauge steel studs that we talked about in the flooring systems. I told you about that company. I think they're a New Zealand company. Has a CAD system tied to an extruder, and they prefab these things. They prefab the whole bloody walls and they truck them out. I got a friend of mine in Montgomery County I told you about that there's not a wood stud in his house, not a wood rafter. It's all steel framing. It's all light gauge steel framing. And the gauges come from light gauge to more heavy gauge. So This doesn't have to be the super light stuff that you see on interior walls in a commercial building. These things can be load bearing, depending on the gauge that they're coal farmed out of. And we talked about that in that section of the book. And then these things are sheathed just like wood framing. Okay. You got horizontal channel bracing. You got diagonal bracing. These things can be welded. You can bring a light MIG welder out on the job site and flux core it. Let's see. You got channel studs. You got C studs. These are usually, these channel studs are lighter. The light gauge ones are used for interior walls in commercial buildings. The C studs will carry a little more weight. They're stronger. They've got a larger sectional density, sectional modulus. Let's see. You fix this just like you do with framing. We've seen these details in chapter 4. They got web stiffeners on the end. We've seen this detail, this floor detail, and then bringing up a secondary wall. Sometimes you can get by with balloon framing, where if it's a second-story building, this whole exterior wall will be one height. Well, this is how you do your interior cripple corners for bringing in your framing. Your manufacturer should have recommendations in their manual. U.S. Steel was a big manufacturer of these coal-farmed steel studs back in my day. Like I said, some of this stuff with some companies, this stuff's formed on site. The steel comes out in rolls, 4-inch, 6-inch, 8-inch, and 12-inch rolls, and they just put a different die in the extruder. And if you need a 12-inch deep C-section that's 20 foot long, then they can make it. You don't have to splice it. You don't have to do nothing. That company builds whole walls in the factory, and then they truck them and erect all of this, so you're not erecting individual sticks on site. It's easy to do truss bracing, and with the modern day foam, spray foam insulation, once you get the exterior sheathing and vapor barrier on there, then you can come inside and spray expansive foam in these cavities after all the electrical and plumbing's run, if it's dried in. There's really nothing else to say. The sheathing is whatever wall treatment you want, how much insulation, and the wall sheathing. And if you want an air gap on the outside, you want to come in and put vertical stringers and then offset your sheathing against your insulation so you have an external airflow in super hot climates out through the top. That's another way of doing it. That architect in Austin does a lot of weird stuff like that, where it's like a skin over a skin. Your imagination is your guide. It talks about balloon framing, and we talked about that before. With light gauge steel studs, this is easy to do. You just extrude out the length. I would look at holding this to 2 stories. 3 stories might be a stretch, but for a 2-story house, 2-story residence, it should be easily done, especially if you incorporate diaphragm flooring in here. It should not be a problem. 2x4 stud spaced at 16 or 24 inches. I would keep them at 16 inches just because it'll keep the drumming effect out of the walls. Your building codes are going to have something to say about that anyway. Factors to consider in the selection of an exterior wall finish or for stud wall frames include your stud spacing, sheathing or backing requirements, your color texture, scale desired. These are factors that you need as a designer to take care of. Expansion joints if required, heat conductivity, durability maintenance, integration for door and window openings, detailings of corners, standard widths, etc., etc., etc. All right, we've seen these details before. We've seen these details before. We talked about fire stops and then fire blocking. You may need fire blocking in here too. Again, your fire code and your local building code are going to tell you what you have to go by. Mileage don't vary. Platform framing. Platform framing is a light wood frame having studs only 1 story high. Okay, this was balloon framing, right? We're done with the steel, so it doesn't matter if it's 2x4s or it's steel, light gauge steel. Balloon framing, you're bringing a whole wall frame up. Platform framing is just that. You got 1 story, and then you set the 2nd story on top and go on up. And there's that crazy roof detail again. At least they stopped the roof joist here. And you got your double seals up here, your double plates. Your seals are down here, sole plate, seal plate, whatever. We've seen these details before already in the other chapter. Again, be careful with these rules of thumb on these spans. Maximum unsupported height is 14 feet for a 2x4 stud. I would not go that. I would not go 14 feet with an unsupported 2x4 stud. Don't do it. I wouldn't go 20 feet with a 2x6 with the kind of wood we get these days. I would not do it. I wouldn't do it. It's certainly, I wouldn't do it. Because most story heights are what, 8 feet? So just stay with the standard 4 by 8 foot sheet, and you got your joist, and you move up with another, and you go joist. Your joist is going to be, this is 8 feet. You got your ledger beam up here. It's got your cap beam, and you're going to set the next deal up here another 8 feet. Stay within a standard module. That gives it whether you're using 2x4s or 2x6s. And if you can afford 2x6s, use those because it gives you much more insulation. 2x6 is what, 5.5 inches deep. 2x4 is 3.5 inches deep. So it gives you another 2 inches of insulation. All right, and it's stronger. Okay. All right. Now, an argument can be made that you'd use a 2x6 down here and then a 2x4 up there. All right, fine. If you can get away with that, then do that. Me, I'd standardize and be done with it. Wood stud framing. We've talked about, I think we talked about this before. Maybe not. Maybe this is deja vu. Your top plate are staggered. Okay. In other words, if this top plate is going all the way to the edge of the wall, this top plate stops right here. This bottom of the top plate stops right there, and this top plate goes all the way through to this edge of the wall. Okay, and then since this one goes there, and this one goes all the way across to the outside edge, this one stops here. All right. This might be a cutout for a joist or something, who knows. But as you come through with your top plates, the bottom of this plate is nailed into the end of this wall. while it's laying on the ground, then you're going to tilt this wall up. So even in conventional wood framing, you're going to set these and frame them on the ground on the slab or the foundation. Get as much of this done as possible. Then you're going to raise this, put jacks, knee jacks in it, keep it plumb, and then set these other top plates across, and it ties this in. Here's an intersecting wall. It does the same thing. This top plate goes all the way through. This top plate goes all the way through. I see what he did. He just gave you a little cutout here so you can see that you're going to end nail that. So this plate down here would go all the way through as one contiguous piece. You'd stop this one, let this plate go all the way out to the edge of that wall, nail down through there, and this is an intersecting portion. It's generally 4 2x4s with nailing surfaces. Sometimes these are 2x6s. This is a 3 block, and it does several things. One, as you can see, it gives you something to nail your wall covering to. This is flush on the outside, but on the inside, you're going to be bringing sheetrock in, and that's going to hit in that panel. And that needs to be set up that way. If not, you're not going to have anything to nail that end of that sheetrock to. And your sheetrockers are going to be cussing you like nobody's business. I don't particularly like this style of corner assembly. I do like this. This is stronger. It's a box. And, but this works. The problem with this is you got less surface area out here to nail to for your outside siding. Where here you have a full face and you've got more room for error. And this is really stronger than this. This is really cheap detailing here. Alright. So if you're going to do a corner assembly, you really want to do something like this. Alright. Maybe it's just that's the way I've always done it. We've really done this mostly all. We use if this is 2x4s, we use 3 2x4s and then take the fourth one in there to capture for the inside wall, and that gives us a lot of nailing surface. All right, this is a inside 3 2x. That gives you a place to nail that wall covering on the inside, and you've got that pocket to set that wall covering in right there, the sheetrock. Okay. The reason we like to build these, including the sole plate on the deck, is we can end nail these things and we don't have to toe nail them. We can face nail them. In other words, this whole wall lays down flat, and then we can drive the nails through the end on the top and bottom, raise the wall up. Now you can't get by, you cannot avoid toe nailing everywhere, but toe nailing is not as strong as end nailing. And if you don't know what I'm talking about, an end nail is that that's 2x4 laying flat on a surface. And this is sole plate. This is that. End nailing means we come in from the end here with super long nails, like 16 pennies, and drive the nails that way. And then over here on the top, okay, this is going to be broke. Here on the top, we have the first top plate. Remember there's 2 top plates? We have the first top plate, and we end nail that. And then raise this wall up as a unit. And these top plates stagger just like they did up here. So this top plate, if this was the wall I just drew you, then this would be long, it would stick out. Okay? And we'd set it up there and line it up on a corner block and all that good junk, and keep going. And then come in here later and put our fire blocking in here. And usually you just use the scrap wood left over from cutoffs. Let's see. This looks like a plumbing block through here where you're bringing pipes up from your slab for a bathroom or something. Who knows? Wood stud framing more. Where are we at on time? We're at 40 minutes. We're probably going to have to do another one. I hope not. Wood stud framing. Now here we have a joist that extends out through the wall. And this is for some reason, maybe this is an exterior patio where some guy can come out here and smoke a cigar. I remember doing this, man. Didn't I do this before? Now he's out here smoking a cigar and bourbon, and this is your soffit. This would be your fascia, but this looks like an exterior wall. But let's just assume that this is a cantilevered porch for Bubba to come out and smoke a cigar, and his wife can stay in here and won't yell at him for stinking up the house. And this is just a handrail. How's that? That would be just a handrail, keep Bubba from falling. Because he's old like me, smoking a nice cigar and drinking a bourbon. Blah, blah, blah. All right, there we go. Okay, all right. No, I'm not an alcoholic. All right, so the underneath covering is called a soffit. This is called a fascia board. Here we have our fire blocking, and here we have our insulation. This is the architectural graphics for bat insulation. Now, I don't really care for bat insulation. I mean, it's been around for a gazillion years. But the problem with bat insulation is after a while it starts to sag and sink. We've got good technology spray foam insulation now that is a whole lot better than bat insulation. Let's see. Interior wall section, a 2x3 stud. 16-inch centers, 2x3. All right, whatever. If this is wood framing, that'd be 2x4. Which is 1.5 inches by 3.5 inches. Okay. Exterior walls, if you can get by, 2x6 is great. It truly is. Here shows the exterior skin going down below your perimeter end cap for your joist, your floor joist system. And this shows 6 inches minimum clearance between finished grade and wood construction. I would say you need 6 inches from the finished grade to any construction, masonry, anything. But that's neither here nor there. All right, headers supporting. These are headers. This is a header. This is a header. This is a header over a window. This is a header over a door. This is cripples, blocking. This is your rough seal. This is your finish seal. These are trimmer studs on both sides. Some people will call these cripples, but they're really a trimmer stud. Your main stud runs unbroken all the way from the seal to the top plate, and then you come up and you put your roughs in here with a trimmer, and then finish this off. You put another trimmer in here, and if you ever work a framing crew, now some places the building code's going to require you to strap them with the hurricane straps or clips. This is using 2 2x6 headers, and no lintels are required. Don't bank on that, depending on your floor load. If it's a single story, you might get away with it. Header supporting. This is what they'll support for spans, 1 story and 2 stories. Your mileage is going to vary. You will check your building codes. For spans over 4 feet wide, header requires 2 inches minimum solid bearing at each end down to floor or bottom. Okay, that's why you're using 2 of these. All right, because you got 1.5 inches and 1.5 inches. That's 3 inches. All right. You might need 1/2 inch plywood spacers in here to make up this difference, and you probably will, because you've got 3.5 inches if it's conventional 2x4, and then you got 1.5 inches and 1.5 inches, which is 3 inches. So in between here, you put a 1/2 inch piece of plywood, and that gives you your 3.5 inches. Okay. All right, plywood box beam. We've talked about making composite beams before. Steel fletched plate bolted to a double header. That's another way of doing it. Framing bolt to steel channel and laminated wood joist, where you just buy a manufactured laminated wood joist and put that in there. There's all kinds of potentials. Stud wall sheathing. No, we're going to finish this. I don't care. What do we got here? Gypsum sheathing. If this is exterior and you use gypsum sheathing on my house, I'm going to fire you. Gypsum does not like water. Now, if you were in the desert, you might get by with that. But down here on the Gulf Coast, that is just ignorant. Ignorant as the day is long. Gypsum sheetrock. And it doesn't like water. I don't care if you're using waterboard or not. Plywood is what you want for your external sheathing over your wood framing or your light gauge steel stud framing. Why? Because it works as a diaphragm. It's structural. It's got laminations going in 2 different directions. Do not use OSB. OSB is trash. That might be okay for a subfloor inside some trash house, but use plywood. You will make a very strong structure that way. You want to stagger your horizontal and vertical joints as you're wrapping the house with your diaphragm. It's just good practice. It's the same as the masonry course. If you have a stack bond where the joints are all going in the same direction, then there's no place for the joints to terminate if they get stressed. So if you can quilt these, checkerboard them so that the joints are not always aligned, that's a good thing. All right, this is rated panel sheathing, and the American Plywood Association gives you a rate for those. We're not going to get deep down in the weeds with the engineering of this. Fiberboard sheathing. That's just almost as nasty as gypsum. A long time ago, they had they'd use sorghum fiber left over from agricultural stuff, and they'd impregnate it with asphalt. It was called Celtex, and I was told that they're not allowed to make that stuff anymore because of the tar that goes into it. But there are people that make all kinds of sheathing, and it's not structural. It's just insulation. So if you come up here and you use plywood, structural plywood as a diaphragm, and then come and nail the wrap it with Tyvek, which is your vapor barrier, and then put your foam insulation board on it, and then put your siding, you'll have a much better structure. Okay, rigid foam plastic sheathing. Yeah, they're going to tell you, and but that's not sheathing, that's insulation. It's not structural. So the best thing to do is to put this foam insulation on top of the plywood and then put your exterior siding, whatever it might be, like hardy plank or hardy sheets or whatever. Okay. Um, all right, wood columns. It's no different than any other. We've talked about built-up wood structures before. All right, the beams. Okay. So these are built-up wood columns. This is a rough sawn column. They're huge. We used a lot of those in that weird shopping center. These talks about different shapes, spaced in between. Your structural engineer, if you're going to get weird, will tell you. Some of those glue lam people will make glue lammed columns, and they will give you a load capacity for them. Here's some more rules of thumb. LD, your mileage is going to vary. I wouldn't stake my inheritance on this. You need to do a full load analysis, and that's why you're hiring your structural engineer. Now, wood works good as long as you can keep it from getting eaten by insects and rot. Okay. Estimating guidelines for wood columns. Again, here's a bunch of rules of thumb. I'm not going to go through all these. It's your responsibility to read it. A 6x6 may support up to 500 square feet. Again, your mileage may vary. And look at this. Here's that word again, may. 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 There's got to be another may in here someplace. All right. So, it may support. Doesn't mean it will. It may. So you need to support your wood structural manual. And again, for wood, it depends on the density of the wood. Where was that piece of wood cut out of the tree? What's the moisture content? How was it kiln dried? You're not going to get a mil spec on a piece of wood or timber that you're going to get on a hot rolled steel from a steel supplier. When I order steel for the welding program, I get steel certs. I get a mill cert. The chemistry of all that steel that we bought. Not that we need it. We're not fabricating pressure vessels or anything, but they send it just because that's what you're supposed to do in the industry. Wood's not that way. All right. Wood post and beam framing. This is the roof, and the floors are no different than the floor systems we talked about before in the other chapter. All right. Post and beam construction. This is all it is. Precast concrete constructions, post and beam, plank and beam, skeleton frame. When the post and beam frame is left exposed, you got to watch out what kind of species and grade of wood is used. You got to get it covered up pretty quick, dry it in, especially down here. All right. When are you going to use treated wood? When are you not? In my opinion, all the base plates need to be treated. All of them. If it's anywhere near exposed to the exterior, the idea is to use a treated base plate. The problem with treated wood, it's got high moisture in it, so you might need to let it dry out a little longer. But for a base plate, it's not that big of a problem. Here's another word, may. Poster columns may be supported by individual piers or by wall foundation. Well, no kidding. We went through all of this for foundations and the details and stuff like that. Post and beam framing may qualify as heavy timber construction if the plank and beam floor and roof structures are supported by non-combustible, fire-resistive exterior walls, and the wood members and decking meet the minimum size requirements specified in the building code. This is a big if. May qualify. Now, this isn't a legal course, but that word may Carries a lot of weight, especially in court. Here's some more rules of thumb. If it's not less than 3 inches, nominal tongue and groove or spline planks with 1 inch nominal tongue and groove flooring or ½ inch, blah, 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 blah. Okay? Roof decking, not less than 2 inches. Nobody uses wood roof decking anymore. Oh my God. Okay? You're talking about expensive. Jesus. Okay? I did some old warehouses down off Washington back when these developers came in and they were going to turn these into nightclubs and bars and, you know, that kind of thing. And, I mean, back then it was cheap to do that. I mean, some nice wood construction. Oh my goodness. Beams and girders not less than 6 inches nominal in thickness and 10 inches nominal depth. Might be heavy timber framing. And columns not less than 8 by 8. Okay? Might be heavy timber framing. Now, what does that mean, heavy timber framing? That goes into another part of the building code in certain sections. And it also increases the cost of your framing. If you're doing light wood framing as opposed to heavy timber framing, you might need a different set of skill sets, a different construction crew. The general contractor is going to charge more for that. All right, post and beam connections again. The strength of a post and beam connection depends on what? This is going to be important. Hint, hint. Bottom line, after all this yapping at y'all, the species and grade of lumber used, the thickness of the wood members, well, no kidding, the angle of the resisting forces relative to the grain of the wood, and the size and number of bolts or timber connections used. The strength of a post and beam connection depends on all these things. Well, hello. All right, timber connections. Let's look at these, and then we're going to call this. We're going to call it a day. We're at 56. We'll survive this. All right. Whether it's load that's in line with the grain, the in distance, or load perpendicular to the grain. Okay. It has an effect. If the load's going down the grain, so the grain's all these little fiber straws going this way, and load going this way, okay, makes a difference in how much it'll carry. All right, and he gives you some rules of thumbs over here. Don't get too lost in the weeds on this. This is structural engineering stuff. This is an interesting connection. It's called a split ring connection. There are all kinds of commercially made wood connections to splice these beams together. I talked to you before about how I did a splice of a beam. Why we're going back through this again, I don't know. Maybe they're talking about built-up columns. It's the same stuff, okay? You can't weld wood together. You can glue it, you can nail it, you can screw it. You can use these mechanical connectors, but this allows rotation, all right? There was a company that made a connector years ago called a Bulldog. It had teeth in both sides, and it clamped in, and the teeth would grab the wood fibers and keep it from rotating. Was it a rigid connection? Not really. You want to make a rigid connection, then start laminating this beam up. Put a sheet of plywood in there with some good glue, epoxy-based glue, pressure, laminate this up, and then you can have more of a rigid connection. So these will work in shear. They won't work in bending. And this is delineating. We're going the wrong direction. Let's go one more down. Okay. This is talking about column base supports, and then column supports for beams, and column beam connections. And we talked about this before. This is, like I said, it's a repeat. This is a beam hanger with concealed flanges. Now, that's a joist hanger is what we called it in the floor joist thing, right? So what difference does it make whether it's a beam or floor joist? That is a hanger. And that is nailed into the column, and then the wood beam comes in here, whether it's a joist or a beam. It's the same deal, and it's nailed in the sides. This is a built-up beam. This would be what we're talking about, laminating the thing with a piece of wood on the inside, and it goes in a built-up column. And this, if it's manufactured properly and you do it right on the site, and you've got the temperature to cure the glue, can make a very strong connection. There's a lot of ifs in there, right? This is a pocketed steel angle with the web stiffener. So you have to route this out, or use a spline cutter, like it's a router with the dado bit on it, and it cuts that out, like for a biscuit cutter, and that slides in there. And then you got to align them holes up and try to find them. If you're going to do this, get one of the heavy duties, the heavier duty ones of these, and just use it. It'll be a whole lot easier. This is going to be a pain to line up. You'll never get it lined up right. I don't care how good you are. This is another one where you're going to use a mortise bit or a skill saw to cut that out, and I guarantee you on the site they're going to use a skill saw. It's not going to be like a cabinet shop. It ain't going to be. So this is a curved beam set into a steel plate. Then you're going to have to line those holes up. And it would be easier just using an offset steel plate and not go through all the monkey motion of curving it. Set the beam up there, bore the holes through the steel plate, use the steel plate as your template, and then do your through bolting. That'd be a whole lot faster and a whole lot smarter. I mean, this just looks cool, but that's going to be expensive. A bearing block bolted to a column, well, that's fine. You can put a bearing block. That's nothing but a wood corbel, right? That we have with the concrete beams, and you set that up there. But then how are you going to support that? You're going to have to toenail it, and toenail it on the top, or have a plate that comes down, a steel angle stiffener, and then nail on the top of that. This is theoretically for heavier loading, or you could use something like this. They make heavier gauges of these. You can bolt it through your column, use lag bolts or whatever, and then do the same thing. And then this gives you lateral stability. It supports the lateral edges of this beam when it gets left to right. All right. Here's a diagonally braced or a knee brace. You set that on a pocket corbel, and then that's screwed or bolted into there to help stiffen up your frame. Again, this is labor intensive, getting all that lined up. Now, this is a problem for wood columns. If it's an exterior, it's exposed to weather, it needs to be treated, and it needs to be ground contact rated for treated. This is another kerf. When you kerf up through this column, you're reducing the strength of the column. I mean, you really are. And then you've got to get this lined up and get that lined up and make sure the spacing between this and the next column is right. You're just asking for trouble using this detail. I mean, it looks all cool because it's hidden and everything, but they're easier to construct details. Here's another. This is an easy one. This is a pocket. This is held, made by the same company that makes these. Strong Tie makes a form of this. This is embedded in the concrete, and then the column sets on there. And it's good to put a shim underneath this because you don't want this bearing on the concrete and water to stay underneath here, because it will end up, even if treated, it'll end up rot down the end grain, because this is cross grain and this is in line with the grain. So this is the end grain down here, and you don't want it to rot up through there. This is easy because now you can use it as your template for drilling and then lag bolting through there. But it's exposed, and you know, this is an attempt at hiding the joint, and there's no reason to hide it. I doubt you'll ever get these lined up perfect. this kind of deal. This kerfing is bad. Plus, you're reducing the strength of your column by cutting all that, hogging all that wood out down there. But that's my opinion as an old structural engineer and a contracting person. You'll set 4 of these columns long before you even finish starting to set that one. I guarantee it. All right, that ends. Right? Oh my goodness. So how long was this video? Oh my gosh, it's an hour and 5 minutes. Well, we'll survive.